Turning on the dry boxes?
Sure.
Okay.
Come over here.
Turn on all of the, we're going to start with the 633, right?
Yes.
Just specifically talking about the 633
Yeah.
this time?
Mhm.
Okay. All right, so turn on all three boxes. And 633 is the second key. If the light doesn't come on, then the interlock's defeated. And I'll come over here if the light doesn't come on. And pull the top ones out. And then go back and cycle the key.
Very good.
Okay, the next step would be to mount the receiver on the goniometer. It's pinned, so it'll slide right on. Use a 5/32 wrench, screw it down. You should edit that though. You don't want to turn on the dry box and the lock-in until this is plugged in.
Okay.
So should keep this off until you got your receiver plugged in. We don't want to hot plug any of the
Yeah,
stages.
it's actually good that we have recorded this, and then, you know.
And remember, if we're not doing polarization sensitive measurements, then you'll want to remove the optics.
Okay.
And there's 3 bolts in the front. Here, I'll grab that stage real fast so you can see how that works. So take off the receiver polarizer stage. These 3 bolts come loose and that comes off.
It's the same for both.
It's the same for both wavelengths. Okay. Next step, we'll mount the source polarizers.
Turn them back.
Well, we'll leave that off till that's plugged in.
Okay.
Make sure you got the right optics for the wavelength you're using. They're marked.
Mm-hmm.
Grab that screwdriver. Plug in the cable to the stage. Tighten it with the thumb screws. Mount the stage on the kinematic mount. Then there's one on the bottom that helps to have a screwdriver for, unless you got real strong fingers. Click that on. Now they're on there. Now we can turn on the drive box. I'll start with that over there.
And the
And the lock-in. Yes. Thank you.
At that point, they have already.
On the software, start the CASI software by double-clicking on the CASI icon. Is that in the way?
no, it's okay.
We can move that monitor over here.
They didn't have to. So, and then a number of years later on the bottom.
We're going to start by clicking the Run CASI, and then single scan tab. Well, first select your data folder, where you want the data to go. And in this case, we're going to leave it in the test folder. And then the single scan tab, and scan file. Select the signature scan, and then click on the manual mode. Now we'll set up the source box. You got to install your wavelength. We're using the 633, so make sure you select the wavelength you want. Okay. In the source box, we never touch any of the optics from here back. The laser beams are co-aligned from this point on. Both the 633 and the CO2 are co-aligned here. So we don't touch any of these optics back this way.
Okay.
Make sure that the flip mirror is down. If you're using the red, make sure the flip mirror is down. grab this thing. There it goes. These won't be in either. Okay. First step, we need to align the optical axis in the source box without the spatial filter, the objective in, or the pinhole. Mount the alignment iris here, and it's pinned in and holds itself there. First step, using this first mirror, we align to this iris. Using the second mirror, we align to this iris. Now it should be pretty close, but if it's not, you just need to tweak it a little bit. So I'll align this up. It's pretty close. Just move it a little. Kind of hard to see that one.
Yeah. Can you just point to that again?
Yep, right here. So this mirror aligned to this iris.
Okay.
Then we'll use this mirror to align to this iris.
Okay.
Now open this iris back up, make sure you're centered, and then do that process again until both are aligned. So I'll check it over here again, and it's a little off, so I'm going to move it again. And then I'm going to open it up, and look here, and we're pretty close. Pretty close. Close this one back up. And that's pretty good. Next step's put in the objective. For the red, there's a 4x objective. And this goes here, and using the knurled knob, tighten it down. Now that we've added the objective, we need to realign the objective now to that same optical axis that we created. So using these two screws, we're going to align this iris so it is centered again. Right about there. And using the black pinhole, that's for the red, the CO2 has a metal one. Place that pinhole here in the closest stage to the iris, and mount the white card on the iris. Now using the Z stage, we'll try to align the spatial filter so that all of the light passes through the spatial filter, and we do that just by turning this in this case, and moving the stage until it's optimal. You want, you know you're there if you can barely turn the screw and the light completely goes away. If I barely turn this, it's gone. I know I'm at the focal point then. So clean up the beam as best as you can. We want it as clean as possible in a nice uniform looking spot. After you've achieved that, look, the iris here, we want to neck down to clean up all this other stuff that's on the outside of the beam, but not so much that we create more rings. like that's too much. I'm going to come back out about there. And the spatial filter is aligned. You can remove this. At this point, you're done with the source box, and we can talk about aligning the laser out on the table. All right, we're going to align the laser now on the outside of the table. The laser beam has to be at 16 inches off the table. We have a ruler for this. We need to move the receiver out of the way. Do that in the manual mode of the software. In the manual mode, we need to make sure we check receiver theta stage. And in this case, I'm just going to move it out 10 degrees, out of the way by 10 degrees. And I do that by clicking in the move by box, typing in 10, and then picking a direction to move. In this case, I'll move it plus, counterclockwise, by clicking the move plus button. Put the ruler in the beam path and see if it is 16 inches off the table. In this case, we're right on the money. If it is not, come over here to the back of the source box, and using the bottom mirror, we adjust it up and down. Not left and right. We don't care about left and right now. Up and down. So I would turn this until it is at 16 inches off the table. We have the 16 inches off the table. Now we need to make sure the laser is over the axis of rotation. To do that, we use this iris, this alignment tool. We mount it in this hole in the X stage. We need to get this out of the way.
And we'll probably get a different iris for that, right? The smaller one?
You can, or this one works. It's just getting this out of the way.
Yeah.
Yep. Once you mounted the iris, we need to move the sample X stage now to 0. Click on the sample X stage. In the move to box, type 0, and then you can either click the move button or hit enter. Okay. The receiver theta is locked down by these two knobs right here, or sample theta stage. So loosen those so that you can freely move the stage. We're looking for the laser to be centered on the iris here. And if it's not, you want to take half of it with the output mirror, half the distance back to the center. I'll do it here, adjusting it. And the other half with the sample X stage here. Once it's centered, rotate it 180 degrees so that the laser's on the opposite side of the iris now. And do the same process until it is aligned. So, I'm back on this one, huh? That was my watch.
Oh, I was like...
I'll take half of it here. And then I'll take the other half with the output mirror. Now remember, we're only doing X. We don't care if it's not lined up this way on the iris. We only care about this way. We're trying to put the laser over the axis of rotation. Flip it back around again. And we're pretty well centered. We're done. Next step, we need a diffuser to align the receiver so that the receiver is looking over the axis of rotation and at the sample. So in this case with the red, we'll use just a piece of Scotch tape. We need to move the tape into the beam. We'll do that by clicking on the sample Y and moving that stage. Good starting point is 0. So in the move to box, I hit selected 0 and hit enter. it's a little too far, so I'll, like, in the move by box, I've typed 2 millimeters, and if I click move minus, it will move the stage 2 millimeters. Keep in mind that the coordinate system is minus means the spot, the laser, will move minus on our sample. So if I click minus, you see that the stage actually goes up, but the spot actually moved down on the sample. Sample Y now. Oop, wrong way. That's good enough. Maybe a little bit less than Y. Okay. We need to make sure that that sample is over the axis of rotation, and how we do that, we have an alignment laser over here, which I'll turn on. Right here. And that alignment laser, which is hard to make out, there, should be at the center of the spot. If you move the spot so that the alignment laser is out in the center, you'll be over the axis of rotation. The other way to do it is to move the sample this way, and you see that the spot itself just spreads out as the incident angle increases. If it was wrong, it would look like this. The way it spreads out.
One way versus the other way.
One way
right?
versus the other. You can see that the alignment laser, the other tinier red spot, here, I'll cover it, is obviously not, they're both not centered on each other. So to bring it back, use the Z stage until it's centered.
How do we know, how do we readjust that laser there when we need to? Say it moved or something?
Remember when we did that with the iris?
Yeah.
The post? At that time, when that is centered over the axis of rotation, realign that.
Realign that to the center of that
Right.
iris.
Once you've got the laser back over the axis of rotation, align it right back to that center of that iris.
Okay.
And then you'll be back to home position, so to speak. Lock the stage down. In the software, if the large aperture is not in the software, click the aperture size drop-down menu and select the large size by clicking on it, left clicking. Now we're going to use the software, the scattered power, to align the receiver so that it is centered on the sample. We do that by turning this set screws on the back of the stage. Pick one of them and do one first, and what we're going to do is we're going to watch the top bar. Once it starts to drop off, we're going to remember where we were. So I'm just arbitrarily picking a direction and turning the screw.
And we're looking at scattered power.
Scattered power, right. The top green bar.
Yes.
Or just the
numbers
value itself. There you can see it's starting to drop off. I'm down to 6.3 e to the minus 6. Now just count turns going back all the way through the peak and then back to where I get back to the 6.3. Your turns will be different than mine, but what I mean by a turn is just I'm just arbitrarily turning the screw a number of counts. So 1, 2, 3, 4, 5, like that. Okay, so I've gone all the way through the peak, and however many turns you come across, you want to go now back half that number of turns. Repeat that process for the other screw. Now the receiver is aligned. So now we can move our goniometer back to 0. We do that with this software again by selecting the receiver theta stage and move to 0. We can take the tape out of the way by just homing the sample Y stage or removing it, either way. On the software, we'll select the small aperture. And we want to roughly align the spot on the smallest aperture by moving the receiver theta stage a small increment, say 0.1 degrees, until it's approximately centered. You can also move the aperture Y stage by selecting on the aperture Y stage and moving it as well. Let's go the other way. If you look here on the screen, you'll notice the gain was going down and then is going back up. Now I know I'm approximately centered on it because I have a low gain value and a higher power, scatter power value. So if I hit close, on this software now we want to center the receiver so that it is centered, the aperture is centered on the laser. So I want to check use current position and then click scan center. Now the instrument will move both the aperture Y stage and the receiver theta stage to center the aperture on the laser. Okay, when the scan is done, when the centering is done, you'll notice here that it actually says the validation is out of tolerance. The validation error is 6.438%. If you see this, click measure center again until it is less than 5%, and usually it will only take one more try. Do you want to go do that again, or do you just want to move on?
We can move on, it's fine.
All right. So once you have a valid center, click the close button, and the next step is to hit total signal. This is your piece of eye measurement in BRDF. This is the most important measurement you're going to make. All of the rest of the measurements use this calculation.
It's the
right?
scaling. It's the.
This is the piece of eye, right? This is the incident power.
Yeah.
You know.
Can you talk about the button above that? How we skip that?
Okay, the validate center button, we skip it because when you scan center, that validation error that it gave you, it just did. So there's no reason to do this again.
It already validates it when you hit that.
It already does. Let's say you decided, this is the only scenario I can think of where you would use it, is if you wanted to check how repeatable the center was. So if you click that again, it will try to validate it again. That's all it's going to do is do that same process again. So since we just did it, we can skip it and go to the next one. Now that we have our measure total signal in watts, we can click close. And this check axis button here, this will move the receiver to the start position of the scan sequence. You'll most likely just skip over that as well because the run fast button will do the same. It will move the stages to the start position and then continue the scan. This button just moves it to the start position and waits for you to click run fast. So you would use this button if you wanted to check where the stage is going to move to, for some safety reason or something. You wanted to see where it was going to go before you started the scan. That's when you would use that. For the most part, you'll skip over it and just click run fast. Now the goniometer is going to run the scan recipe that we put in, the signature scan recipe. When the scan's finished, click good, accept the scan, and then save the scan with a file name. In this case, I use the date 0523 12, and then since it's the first one of the day, I type 01, and then I use the wavelength as the extension. So in this case, .633. If you'd like to make notes that get saved with the file, you can. Like, for instance, I can write signature for signature scan, or just SIG for short, and then save and close the file. At this point, we're ready to. It'll ask you a question here. Signature scan has completed successfully. Use as the signature scan. Say yes. And we're ready to set up for a sample scan. Want to measure a mirror, probably? Measure
Sure.
the Molly?
Yeah, we'll do the Molly mirror.
Okay. So we're going to set up to make a sample scan. At this point, you're ready to actually make some data. So under scan file, in this case, we're going to select a predetermined scan that we already created for the Molly mirror, our sample, at a 5-degree angle of incidence. So select that, click open, and then we'll skip down here to the check axis button to move the stages to the 0 position. In here, you're given a list of options. If you have all the stages plugged in, if the source polarizers are plugged in and the receiver polarizers are plugged in, you can click Move All, and it will move them all. I'm going to get that monitor out of the way. It's about to turn the goniometer all the way around.
So what axis is it checking?
It's moving all of the axes, every one of them that it needs to move to get to the 0 position, and to get the sample in the recorded position from the scan definition file. So you'll see it'll now move X and Y. I gotta cut these off.
So we're doing reflectance measurements now.
This is a reflected.
So the goniometer will be towards the light box.
Exactly.
And the transmission measurements, the goniometer will be towards the end of the table.
Yep, exactly. Yeah, signature scans and transmissions, the goniometer is over here. Reflection scans, the goniometer is over here. Make sure that when you're moving the goniometer around and you're going back from a reflection to a transmission, that you don't take the goniometer all the way around this way, because you will pull the cables out of the goniometer. Make sure that when you're over here that you always go back the way you came.
And how do you do that? And how do you make sure? Is it in the scan?
The goniometer knows to try and go that way, but for some reason, if it gets confused or you get confused and you manually try to move it, right? If you say go from 180 degrees plus, it's going to try and go 180 degrees plus.
Is it on manual mode right now?
No.
No, it's not.
Not right now. It's automated. Yeah. So we're going to go back into the manual mode by clicking the manual button. Can you see that over there?
Yeah, we need to tip that down just a little bit here.
And Molly
Oops.
here. Grab a glove. We're going to mount our sample on the sample Y stage. Right. Now we need to make sure that the sample is perpendicular to the source. To do that, we use our ruler again. Unlock the sample theta stage by turning the 2 screws, and rotate the beam so that it's on the ruler, or whichever measurement you have, or device you have, and move the stage until you're centered on the 16 inches off the table again. You can also use the small aperture as well. You need to make sure now that that spot is over the axis of rotation, and you can use the alignment laser again by looking at the spot and seeing that the two are centered. Both this spot and the alignment laser spot are centered on each other. If they're not, move the Z stage until they are. Now we mean centered this way, not necessarily centered this way. The next step would be to make sure that on the software that the sample theta location move to 0 degrees. Then using the reflected beam, we're going to align it back up on the mirror so that we have 0 degrees. Here, I'll block this one so we're not confused. Keep in mind that there is a reflection off this as well. It can confuse you. Then in the software, once you have it locked down to 0, move it to your incident angle, whatever that for your measurement. In this case, it's 5 degrees. And you can see that it lines up on the aperture. The other way to do that would be to line it up directly on the aperture. Leave the sample theta at your desired incident angle and align it to the smallest aperture here on the receiver. Once you have that, now you can scan center, just like before. We'll skip the check axis button and go to scan center. We want to make sure we tell the software to use the current position. This is where we want it to stay. Even though we didn't move it, it wouldn't have tried to go anywhere, but just out of habit I say, you stay here. Scan center. If you see that aperture Y, measurement aborted, offset not changed, just click measurement center again. Measure center again. You can see we have a valid center. Validation is good. It's less than 5%. We can click close, and we can take a total signal. There we have our total signal. We hit close, and it should be the sample's reflection is right here. And after that, we can click run fast or run slow. If it is a very smooth surface, very low scatter sample, you'll want to run slow.
Do we have to use current position on this one?
You don't. It's already did it, right? We did it when we centered it.
Oh, okay. Okay.
Right? So we're already past that point. Yeah. And
One thing I forget, so.
Yep. Keep it. That's good. Then we'll click run fast to start the scan. In this case. Normally with mirrors, you're definitely probably running slow.
Mm-hmm.
And that's the sample scan. Is to export into Excel ASCII files. To export into Excel or some other program, you go click on the Edit CASI, and then select the file you want to export. You see options. We're writing Excel batch or writing ASCII batch. That Excel just creates a CSV file. The ASCII it's an ASCII file. You can click on these two buttons if you want to create a bunch of them, or you can click on the file in the drop-down list, and it will just create a duplicate of this particular file. So, like I think in this case, we write ASCII BSDF. Now, this is the save the file as, so this would be the ASCII file name. So if I say Molly ASCII, and say save
believe that's the process.
And there it created it. It doesn't look like it did anything, but it did. Now we're ready to open another file if we want to do it again. So it's selecting a file is what it's asking. That's it in a
If you
nutshell.
select a batch of them, it'll make a folder with all the files in the folder.
Yep. The other thing I should show you as well, I don't know, you don't want to record this or not, but in the manual mode, let's say you want to sit there and take data manually. You want to record the power measurements of let's say the reference detector or the receiver. You can have it write the power measurements to a file. If you click setup down here, it will save to the file you select here in a comment. It will save the parameters, whichever parameter you select, every time you click save. So if I click save, boom, it writes it to that file. If I click it again, it appends it to the file. So it just keeps adding data to the file. I forget which customer wanted that. Somebody said, hey, this would be really useful. I thought, oh, okay. So,
That's
there's a little hole
how to
here.
co-align if it gets moved.
There's a little hole here with a plug in it. If you pull that plug out, the beam can come across the table.
Well, you have to
It'll be in the way of the goniometer.
pull that mirror.
Yeah, we'll get there, yeah. The beam can come out. You have to remove this mirror right here. There's just a set screw, bolt. Take this mirror out so that both lasers can pass out of the source box directly. I'll move this goniometer out of the way. See how it went the right way? When I clicked home stage, it
Yeah.
knew to go that way home, even though it was shorter to come this way home, right? Okay, so once we got the lasers passing out of the source box, we're going to mount an iris here, smaller one, here, and align it to the 10.6, where the 10.6 is coming out, the red diode from the 10.6. Mount another iris further away and align it to the 10.6. Once you have the centered on the irises, both irises centered, the CO2's red diode is centered on both those irises, you can flip the mirror down, the little mirror for the red, and then using this mirror up here, you would line to the first iris. Using these two knobs, you would line to the furthest iris, the iris that's furthest away from the source box. And iterate back and forth until it's centered completely on the irises. At that point, both beams are co-aligned, and you don't want to touch anything back here. Okay?
But we just do this for the red. We don't use the CO2 on it.
CO2 is fixed. See, it shoots straight, so
Right.
there's no way to move its beam.
Right.
And you want to align the red one to the one that's stationary.
Okay.
Right? It has two mirrors, so it has 2 degrees of freedom.
Mhm.
So we can move it anywhere.
Yeah.
Right? He's fixed.
Where do you put the irises though?
Wherever he is.
You're aligning the irises to the CO2?
Wherever, yes.
Or to the red?
It's the red alignment
The
laser
red
on
alignment,
the end of the
yeah.
The
CO2.
CO2.
Right, you don't want to run this thing.
We're aligning that to the heme.
Just turn the laser on
Yeah,
so that the diode's on, but don't turn the CO2 on. Right?
okay.
So
the diode will
the
come out.
Heaney and the red laser from this guy will be co-aligned.
Will be co-aligned out here.
Always.
And
Yep.
it's just at this height.
Yes.
So we need a small little.
Yes. And then once you have both of those two co-aligned to each other, screw this mirror back in, mount this mirror back in, and rotate it so that it comes up through the center of the hole up here. Right? Through the center of that hole.
Where's your finger? Hold on. Okay.
And then it should hit the center of this mirror at that point. And now you're ready to align, do the standard setup procedure and align these, using these two mirrors, align it to that optical axis again. This mirror for this iris, this mirror for this iris, which will be mounted right here. And then you can replace the plug.
Did you record that beginning part when you started?
No, that's usually done at the setup, and then we don't. There's no reason for you to do it